Hi, this is Klaus from Lemonade, and today I'm gonna show you how we use Lua coroutines to create real-time cinematic sequences in the game Mars Lags. From a game developer's perspective, cinematic sequences are times when our code takes control away from regular in-game logic in order to have important events happen in a predefined way, and also to guide the player's attention so they won't miss it. Let's take a look at our example, the Mars Lags intro cinematic. First, at the very start of the sequence, we notice that most of the in-game GUI gets hidden, and the game timer is halted. Also, the camera has been moved to a vantage point next to the landing site, and looks at the spaceship, which itself has been placed high up in the Martian air. Then the ship descends, and once it touches down on the surface, some keyframe animations are replayed. When concluded, the camera moves all the way to the other end of the map to the rover's starting position. And finally, in-game controls are reactivated and the game timer resumes counting down. And throughout the entire sequence, various lines of text are displayed on screen to help establish the setting and the player's mission. Now, for all that to happen, our cinematic code must interact with various subsystems of our game: the GUI, the ship, the rover, and of course the camera. And we also need to precisely time and coordinate those interactions. This becomes much easier to do if we keep all relevant logic in one place, and that is where coroutines come in. Coroutines allow us to write functions where execution can be paused and resumed as needed, for example across multiple frames and update cycles of our game, while maintaining their own local scope. In our case, we want to check in with our cinematic function during each frame to monitor progress and occasionally kick off the next thing that is supposed to happen. Let's have a quick recap on Lua coroutines. In their most basic form, they are operated by calling three member functions of the global coroutine object, which are create, resume, and yield. Create prepares a function to be run as a coroutine. Resume then causes the execution of the function to continue, either from the top or from wherever it was last suspended. And lastly, yield, called from within that function, causes execution to be suspended. Let's go and see how this works with our intro sequence. Our CRIntro coroutine function goes through four phases: an initial setup, then two phases where things happen over time, and then a final cleanup. In the setup phase, we set the rover to not controllable, which causes the rover-related GUI to be hidden. Also, we flag the game as paused, which keeps the game timer from progressing. The next phase models the ship's arrival. First, we pass a custom control function to the camera entity that will move it next to the landing site and make it keep looking at the ship. We also enqueue a batch of narrative texts to appear on screen during this phase. And of course, we must tell the ship itself to perform its descent and deployment. Here comes the first time we call coroutine yield. So actually, up to this point, everything we said will happen at once, and right before the first frame of our cinematic is rendered. The enclosing repeat loop then is simply us waiting until the landing has played out. The next phase models the camera moving back across the map to the rover's starting position. Here we simply animate the camera with a custom controller function and we wait for that to conclude. Next we add some more text for immediate display. And to give the player a bit of time to notice it, we let the camera linger for a moment at its final position behind the rover looking at the ship. And again, we do call yield to wait until the respective time periods have elapsed. Lastly, we clean up the mess by setting things back to what we need for playing. We release the camera from any custom control functions. We set some instructions text to be shown. We reactivate rover controls, and finally we unpause the game to resume the game timer. Now let's see how this function is used. The function is part of mission control, one of the top-level entity scripts in Mars Lags. In there, it is passed to an event that is scheduled to trigger right at the start of a new game. And when that happens, the coroutine object is created and stored, and also immediately resume is called on it for the first time. In the script's update lifecycle function then, we check for such an object, and if it exists, we call resume to allow our coroutine function to progress from where it left off during the last cycle. We also check for the object's status, and if it says that the function has returned, then we discard it. But what about skipping the intro? In Mars Lags, we allow the user to do that by hitting the escape key. And that is why, back in our coroutine function, we must check for whether that happened. And we do that every time the coroutine is resumed, that is, after each yield. Once our skip sequence flag has turned to true, all remaining phases in our coroutine behave such as to conclude their business instantaneously. The landing animation in progress is no longer being observed, although it will keep running. And the part where the camera travels across the map is completely skipped, or abandoned if it was already in progress. Now for the last loop, where the camera lingers behind the rover for a moment, we make sure to not skip over assigning our control function, because it will move the camera to where we want it to be at the end of the sequence. And finally, in the cleanup phase, we actively remove all lines of narrative text that may still be queued to appear. Now, in case you wonder about all the landing ship action, that's actually done in another coroutine. It is kicked off right here, but then it will run independently and is actually defined and controlled by another script, the landing ship script. And we do that because this way we can keep the details on how to operate a spaceship nicely encapsulated and outside of mission control. Looking at that other coroutine function called CR sequence arrival, we can see that it first causes the ship to descend to the surface, then comes the point where we turn off the engine exhaust effect, and finally we run the keyframe animations that would open the ship's hatch and extend the ladder. Now you may wonder why this coroutine does not care if the intro was skipped and will just run its course. This is intentional, such that in case we do abort watching the intro, we can still see the ship landing here in the background. We hope this can help illustrate how Lua coroutines offer a clean and flexible way to orchestrate complex sequences and for you to enjoy creating real-time cinematics for your games in Lemonade. Thank you for watching.